All right, so I'm here with David Adell. We are talking single length, and a question that I hear all the time is how does the 4-iron, how do the long irons go far and go high? David, what's the answer?
It's a good question. It's a very complex one, and one that wasn't, well understood back when single length first came out back in the day, in the late '80s with Tommy Armour. But what we're able to do with the 4-iron that we weren't able to, do in the old days is it was the flex face technology. Having this hollow body design with a very hard, springy, thin face. Another attribute that allows us to maximize the potential of the 4-iron is the normal 4-iron is probably going to weigh like 241 grams to 243, 240, depending on the maker. Now we have a golf club that's 30 grams heavier. So it's a force times mass acceleration kind of a scenario. So if you're hitting a golf ball that weighs 1.68 ounces and you're hitting it with, relatively the same speed, there's a perception that a longer golf club moves faster. That isn't necessarily true. And when you hit it with a very perpendicular force, a 4-iron is more perpendicular than a wedge, you're not going to lose energy due to the spin. That if it's 30 grams heavier, which is over an ounce, so it's more than 50% of the mass of the ball being hit with more mass, that ball is going to fly farther. So it's really a force times mass acceleration thing, that the difference in 2 inches of length is not as important as the amount of mass increase that's in the head of the golf club, combined with flex face technology. And then in our specific case, using our Patterson Kinetic single length shaft with the long iron profile is going to provide more spin and more energy release in this shaft profile, designed specifically for single length. As the fitting process goes along, we'll see, generally speaking, an immediate improvement in lateral deviation. And my centeredness of contact is so much better. So we get more consistency in the spin rates. We get more consistency in lateral deviation. Once we get accustomed to working on one golf swing, the plane of the golf swing is phenomenally different than variable length, where you have different swing planes. So locating low point of the golf club to the ball is so much more consistent that just immediately improves dispersion and deviation. On the other end of the spectrum now, we got a pitching wedge in our hand, and a normal pitching wedge is going to be around 293 grams. Well, now we have one that's 270, 272, or 268, right? So now we have less mass hitting the golf club. Though it is longer, it will provide generally a little more club head speed, but a lot of energy is lost in the golf ball through spin loft and the reduction of mass in the head, right? So we have less energy being imparted to the golf ball because we have less mass in the head, and the loft is dissipating quite a bit. Single length do fly, generally speaking, a little higher, but because we have designed in our situation a Patterson Kinetic shaft that provides less energy, for lack of a better word, to simplify it, it's a deader shaft, so it drops the trajectory and lets less energy be emitted due to the winding patterns in the shaft, in this advanced Kevlar graphite matrix, that we're able to dissipate energy in that way also. We also have thicker faces and a little higher CG in the pitching wedge, gap wedge, that were designed to make the face not as lively as we would have it in the 3, 4, and 5-iron to gain distance. So we've done everything we can to lower the trajectory and decrease distance in unique ways that no one's done in the industry.